Here we have a quadratic function, and we want to find the vertex, find the axis of symmetry, determine whether there's a max or min, find the range, and we want to graph the function. So the name of the game is finding the vertex. Once we find the vertex, that tells us pretty much, or leads us to all the pertinent information. So when we are in this form, and this form is ax squared plus bx plus c, we call that general form. To find the vertex, we use negative b over 2a, and then f of negative b over 2a. So b here is negative 10, so opposite of negative 10 over 2 times 5. We get 10 over 10, which is 1. So this is the x value, or the x coordinate of the vertex. Then we input that value, so that 1 goes into the function, and we evaluate. So I get 1 squared is 1, times 5 is 5. 10 minus 1 is 10. Or negative 10 times 1 is negative 10. Plus 3, so we get negative 5. Plus 3 is negative 2. So the vertex is the point 1, negative 2. Okay, so 1, negative 2. Putting that onto the graph, positive 1, negative 2, there's the vertex there. And the original function is f of x equals 5x squared minus 10x plus 3. So the leading term, or the leading coefficient, is positive. So that tells us that this parabola is going to open upward. Now, from here we can find most of the other info. The axis of symmetry is going to be this line that cuts the vertex right in half. So the axis of symmetry is going to be the line x equals whatever coordinate, whatever x coordinate of the vertex is. So x equals 1 is the axis of symmetry. This graph has a minimum value, so right here is the minimum, and we would say the minimum value is equal to negative 2, and it occurs at it occurs at x equals 1. So when x is equal to 1 in this function, we get the smallest value of the function, which is negative 2. If the graph were to be opening downward, then the graph would have a maximum value. The range, well, the range is just whatever y values that this graph hits. So the smallest y value that the graph hits is negative 2. And then the greatest y value, well, it goes all the way up to positive infinity. So we'd say negative 2 to infinity. We don't include infinity in the interval, but we do include negative 2 because the graph actually hits negative 2. And then the last thing we want to be able to do is write the function in vertex form. Now there's kind of a shortcut cheating way we can do this, or a longer way. I'll do it both ways. So vertex form is f of x equals a x minus h squared plus k, where hk is the vertex. So we already know the vertex. We found the vertex back here. It was 1, negative 2. So h is 1, k is negative 2. And the a value is the same value in the original function. So putting this into vertex form, we're going to have f of x equals 5x minus the h value, so x minus 1 squared, plus the k value, so plus negative 2. So I can just write it like that. So that's the shortcut way to get the vertex. The long cut way is to complete the square, which when we have a leading term that has a coefficient that is not 1, this is when we sometimes run into trouble. But what we want to do is factor out the 5 from the first 2 terms, leave a space, and then we say, what's half of b? So half of negative 2 is negative 1, and then we square that. Negative 1 squared is positive 1. Now, by adding that 1, what I really have done to this function is I've added 5 times 1 to the value of the function. So to keep the value of the function the same as before, I need to subtract 5. I added 5, so I also subtract 5. So I've completed the square, x squared minus 2x plus 1. So that factors to x minus 1, which is what we want. We want the same two factors. So I can write this as 5x minus 1 squared, and then 3 minus 5 is negative 2. And that is a second way that we can get vertex form by completing the square. Either way, though, we get the same function.